Hey, welcome back to my YouTube channel. I'm Xavier Smith, and today I'm going to be talking about vectors. You may know about Vector from Despicable Me, where he's like, Vector, oh yeah. And he says, like, vector. They're like, what is vector? Well, vector is a line segment with direction and magnitude. So he's like, direction and magnitude. So you may know that. Well, now we're actually going to take a dive into vectors and see what they are, and then talk about direction and magnitude. So let's go. Vectors are defined as a directed line segment. So it's a line segment, and then it's got a little arrow on the end, meaning it keeps going, but there is like a specified segment between them. And it's just directed, and you'll get to direction down here. Okay, and with a vector, all you will have is an initial point and a terminal point. And if it's in like a component form, which we'll get to next, you will only have the terminal point, and you will assume the initial point is 0, 0. Okay, so here, if we had the vector with initial point negative 1, comma 2, then we could just graph negative 1, 2, which would be here, and then terminal point 4, comma 3. So 1, 2, 3, 4, 1, 2, 3. This would be our start point. Terminal means end. So we'd go over here and then put the arrow. So we would go to this terminal point, and then the arrow means we just keep going. That's where the direction comes from. Because if you just put a line segment, there's no direction to that. But this shows that this point over here is our initial, and this is our terminal. Okay, component form is where you put these little like carets on the end, and you say, okay, terminal minus initial, and that will give you component form. So down here you'll see like caret 2 comma 4 caret, meaning that you go from 0, like you start at 0 as your initial point, and 2 comma 4 is your like final point, your terminal point. Okay, so if we were to do this in component form, we would do terminal minus initial. Another thing to look at is there's standard unit vectors that you can use. I is just your x component. So instead of putting it in like parentheses form, saying root, well, parentheses negative 1 comma 2 minus parentheses 4 comma 3, you could just say, well, negative 1i, so negative I is, so x component would be I, and j is the y component, just to make it a little simpler. So this is terminal, so we'll start over here. So this is 4i plus 3j, because j is y component, minus, I'm going to put the parentheses to show we have to distribute, negative I plus 2j. Okay, and now this will be 4 minus negative would be 4 plus 1. So this would be 5i. 3 minus 2 would be 1. So minus j. So once we have 5i minus j, we can say, like, just turn it into caret. Get rid of the I and j, and the I is just the x, and the j is the y. So this will be caret 5, comma, this should be plus, sorry about that, 3 minus 2 is 1, not negative 1. So this will be 5, comma, 1. Then we go over 5, go up 1, and this is ours. You could just label that 5, comma 1. And you can see it's the same graph, but we just put it down on starting at 0, so we just shifted the graph. Okay, now our magnitude, if you're trying to find magnitude, equals length. So you could do distance formula, which is like x2 minus x1 squared plus y2 minus y1 squared, and it's the root of all of that. Or you could just do the Pythagorean theorem. You could just say, we have these 2 points, and we know like how far this is. So if we just made this into a triangle, we'd have this, this. We know it's 5 over, so this here would be 5. And then we know it's 1 up, so this would be 1. And if you're just finding the distance, that would give you the magnitude of the vector. So it would just be 5 squared plus 1 squared equals whatever this is. That would be 26 equals this squared. And then just root 26 would be your answer. If it simplifies, could simplify. I'm not feeling like it right now. Okay, so that's how you'd get magnitude. You could use Pythagorean theorem, or you could use this distance formula. And then your direction is just your slope. So slope is super easy when in component form because you have 0, 0, and 5, 1. It's just rise over 1. So 1 is our rise. So 1 minus 0 over 5 minus 0 equals 1/5. That's our direction, is 1/5. Because you can see for every 5 we run, we go up 1. Okay, and then vectors, like equal vectors, have equal magnitude and direction. So if you get two things with initial and terminal points, turn them into component form. And if they're the same, then they're like, if they're the same, like caret thing, they're probably good. You might, if they're different, you could still check one of them. And if one of these doesn't work, like if the direction, like the slope's different, then definitely not the same vector. Okay, then you can add and subtract vectors. We're just going to add a vector. Add two vectors. So vector u is caret 2, comma 4, caret, and vector v is caret -3, comma 2, caret. So I could turn these into i's and whatever, but I don't really have to. I'm just going to say, okay, 2 plus -3 is -1. Got that one. And then 4 plus 2 is 6. And just caret, caret, and that's u plus v. So we'd go -1, 6. 1, 2, 3, 4, 5, 6. That would be our solution. But another thing you can do to approximate solutions is draw these two vectors and then finish a parallelogram. So 2, 4, 1, 2, 1, 2, 3, 4 would be here. -3, 2, 1, 2, 3, 1, 2. This. And then you just finish the parallelogram. And then the diagonal will be your like estimated point, your addition point. So -1, 6, but you can see the estimate parallelogram is like right on there. So I hope this video was helpful, and thank you for watching.